Hi students, welcome to Preliminary Chemistry and the water topic, and this is video number 16, Measures of Concentration. Now last video we introduced the idea of molarity, and molarity is the most commonly used measurement of concentration in the laboratory. We used a formula to calculate it, the number of moles divided by the volume, and this gives us units of moles per litre. Commonly, you'll see most of the substances in the laboratory listed in terms of the concentration as, say, 2m, which just tells you that it's 2 moles per litre, and that's its concentration. However, this is not the only measure of concentration that is used by chemists. In fact, there's quite a range, and some of those will be explored in this particular video, including percentage by volume, percentage by mass, grams per volume, and parts per million, either in terms of volume or mass, or even a combination of these. The first one I want to have a look at is percentage by volume. Percentage by volume is defined as the volume of a solute expressed as a percentage of the total volume of the solution, and the units are percentage V/V. This is most common in alcoholic beverages. So for example, if we know that a certain type of beer has a alcohol percentage of 4.2%, what that means is effectively it is 4.2 mils in 100 mils, or 42 mils per litre. Because it's expressed as a volume to volume, this is usually for substances or solutes which are liquids dissolved in other liquids, and that's why we get our volume to volume. So medicinal labeling often this way, cough mixtures and so forth. Some foods are listed this way, and as I mentioned, alcoholic beverages. Percentage by mass is more common obviously when the solute is a solid, and it works exactly the same way as percentage volume to volume, but it's more common for things that are more of a solid type of arrangement. And of course, if I use the same sort of thing, 4.2 percentage, but this time weight to weight, the W to W is weight to weight. So that in this case would be, say, 4.2 grams per 100 grams, or 42 grams per kilogram. Okay, so these are the sorts of measurements that we can often get for substances which are solids, as opposed to the liquids that we get when we use percentage by mass. Now, sometimes it's useful for us to use a combination of these. Our molarity is a good example because it's the number of moles per volume. This is also a similar one where we don't actually convert the mass into the number of moles, we leave it in its mass units, which is grams. So often you'll find things listed as grams per litre. This is quite a useful measure because we know that water has a density. The water density is 1 gram per mil, or 1 kilogram per litre. And so this makes it nice and easy for us to do calculations and also have a look at different types of concentrations and make comparisons. One simple example of this is the saline content of seawater. So we can identify how much salt is in seawater by looking at the number of grams per litre that are present. The other two that I want to quickly have a look at are for concentrations where the amount of solute is very, very low. In fact, I'm going to leave discussion of even lower concentrations, which could be parts per billion. But we're going to have a quick look at these two examples, parts per million in terms of volume, and also in terms of weight or mass. When we're looking at volume, what we're looking at is the volume in milliliters per kiloliter of solution. The units are ppm, and then V to V in the same way that we looked at the percentage earlier on, but this is for very small quantities. So maybe the concentration of a particular pollutant in air, such as the concentration of carbon dioxide, or the concentration of sulfur oxide, or nitrogen oxides, something like that. The way that it works is if we had 1 milliliter, we would say we had 1 part per million if we had 1 milliliter in 1 million milliliters. Okay, so this would be our solvent or our solution, and this would be our solute. So when we contract that, that's the same as 1 milliliter in 1,000 liters. 1 million milliliters is the same as 1,000 liters, or 1 milliliter in 1 kiloliter. And this is equivalent to 1 part per million. And that's what we looked at in our top line here. So 6 parts per million would be 6 milliliters of a particular substance in a kiloliter of the total. It should be obvious that the same thing occurs for when we're comparing parts per million for masses, except this time we're looking at milligrams per kilogram. Do the same thing and you get 1 milligram in 1 million milligrams, 1 million milligrams, which is the same as 1 milligram in 1,000 grams, or 1 milligram in 1 kilogram. Okay, this is quite useful for solid particles. Water pollution can be done this way, and particularly because we know that the density of water is 1 gram per mil. And also you can find sometimes the environmental pollutants, particularly heavy metal ions, for example, can be expressed as parts per million, where we're looking at the mass of the ion and the mass or the volume of solution, because 1 kilogram of water is also going to be equal to 1 liter of water. So these are just some different concentrations, and you'll determine which is the most appropriate based on the level of concentration and the type of solution that you have. Thanks for watching.